So welcome all to the lesson, and we begin from where we had stopped yesterday. That is the paper of November 2018. November 2018, question number 3. So it says, explain the following terms as used in hypothesis testing. 1, level of significance, and number 2, region of rejection. Region of rejection. So that is the question of November 2018. November 2018, question 3A. It is coming from hypothesis testing. Hypothesis testing. That is where it's coming from. And specifically, we are told to define terms. We are told to define terms. So the first term is level of significance. The first term is level of significance. Level of significance. So level of significance, this is the probability of rejecting a null hypothesis, when it is true. The probability of rejecting a null hypothesis when it is true. Number 2, region of rejection. Region of rejection. Region of rejection. So the region of rejection is defined as the interval measured. This is the interval. The interval measured. The interval measured in sampling distribution. Sampling distribution of the sample statistic. Sample statistic at the study that lead to rejection of null hypothesis. That lead to rejection of null hypothesis. Null hypothesis. Number 2, we are told summarize the factors that determine the size of the Pearson product moment correlation coefficients. So that is now question 3B. Have you finished copying that? If you are through, say yes. Yeah, I can see we are through. Good. So let's go to the next question. Part B says, summarize the factors that determine the size of the Pearson product moment correlation coefficient. The factors that determine that size. The factors that determine that size. So that question is coming from regression and correlation theory. Regression and correlation theory. That is where it's coming from. So the first thing, we are told to talk of factors that influence. Factors that influence Pearson's product moment correlation coefficient. Correlation coefficients. Coefficients. This is the one that we normally refer to as R. Is the one that we normally refer to as R. Normally refer to it as R. So the factors that determine the size of that are, number one, variability of data. Variability of data. That is one of the factors. Number two, we have presence of outliers. Presence of outliers. These are values that are extreme when they are compared with the others, either very high or very low values. Number three is lack of linearity. Lack of linearity. Number four is characteristics of the sample. Characteristics of the sample itself, as in size, randomness, and so on. Characteristics of the sample. Number five is measurement errors. Measurement errors. Measurement errors. Another thing that you can say influences is skewness of the data. Skewness of the data, or the difference in distribution or the shifts. Yeah. Those are some of the factors that influence Pearson's product moment correlation coefficient. want to proceed to the next question. That is part C. Part C. The question says, the following data were obtained from the records of a certain company relating to the year 2018. Now required the least squares regression function, coefficient of determination, and you comment on the results. You comment on the results. I have been telling you, when you come across that kind of a question, the first thing is to give us the format. So least squares method, least squares function. Now the format is y is equals to a plus bx, where b, we have been saying it is n sum of xy minus sum of x, sum of y. You divide this by n sum of x squared minus sum of x. You square this. That is how you get b. Then if you are looking for a, it is sum of y minus b sum of x. You divide by n. The other one that we are told to get is coefficient of determination. Coefficient of determination. Coefficient of determination. Coefficient of determination. Now this is r squared, which is supposed to be given as n sum of xy minus sum of x sum of y, then n sum of x squared minus sum of x. You square this, you multiply by n sum of y squared minus sum of y. You square this. Then the whole of this now, the whole of this, the whole of this, we will get to square that. We will get to square this. We will get to square that. Get to square that. From there, we have again been saying you require to prepare what we call analysis table. Prepare the analysis table, and this analysis table has several columns. The first column is the values of x. We are told 856, 536, 640, 600, 680, and 808. So you say 856 plus 536 plus 640 plus 600 plus 680 plus 808 is 4120. Then you bring the values of y, 14,250, 13,000, another 13,000, 12,500, then 13,250, then we have 13,750. So if you say 14,250 plus 13,000 times 2 plus 12,500 plus 13,250 plus 13,750, you record 79,750. 750. I require a column where x is squared. Today I want to do it in a manual way. So 856 square is 732, 736. 536 square is 287, 296. 640 square is 409,600. 600 square is 360,000. 680 square is 462,400. 828 square is 652,864 plus 462,400 plus 360,000 plus 409,600 plus 287,296 plus 732, 736. I record 2,904,896. 896. The journey continues. I need now to bring x multiplied by y. So 856 times 14,250 is 12,198,000. 536 times 13,000 is 6,968,000. 640 times 13,000 is 8,320,000. 600 times 12,500 is 7,500,000. 680 times 13,250 is 9,010,000. 808 times 13,750 is 11,110,000 plus 9010 plus 7 plus 83. exponential 4 plus 69,68,000 plus 12,198,000 equals 55,106,000. The last column I need to bring is called y squared. It's called y squared. So y squared is 14,250 squared is 23,062,500. 13,000 square is 169 million. 169 million. 12,500 square is 156,250. 13,250 square is 175,500. 13,750 square is 189,062,500 plus 175,562,500 plus 156,250, 123 plus 169 exponential 6 plus 169 exponential 6 plus 203,062, 500, get 1,061 million, 937,500. So I hope we are together at that point. If we disagree on any figure, you let me know quickly. If we disagree on any figure, you let me know quickly. So from there, substitution. I want to start with r squared because of the space. R squared. So these are 1, 2, 3, 4, 5, 6. So there are 6 of them. So 6 times sum of xy, that is 55,106,000 minus sum of x, 4120 times sum of y, 79,750. Then 6 times sum of x squared, 2,904,896 minus sum of x squared, that is 4120 squared. Then times 6 times sum of y squared, 1061, 937,500 minus sum of y. Sum of y is 79,750 squared. 750 squared. Then tukasema the whole of this, we will get the square. The whole of this, we will get the square of it. So I want you now to give me the answer so that I see whether we are together. I want you to give me the answer so that I see whether we are together. According to Mohammed, 0.9, is it squared already? Abel, I think you need to revise that. 0.8114. Good. 114. Which you can express as a percent. If you multiply by a percent, if I come back here and multiply by 100, then I will talk of 81.14%. You can either give it as a decimal or as a percent. So you can multiply here by 100 or leave it. So I can see the answers from Mohammed, from Abel. Abel, you look at your answer. Cynthia, that's okay. Siobua, Eliana, and Aisha. So the others, Quinta confirms. So the next thing, if we are okay with that, the next thing to Nabiwa we interpret, we comment on the results. The interpretation or the meaning, interpretation of that figure, is that 81.14% of total overhead costs in the above case is caused by or is explained by direct labor hours. Is caused by or is explained by direct labor hours. I have not skipped. Eliana, we are on course. So once we are through with that, it is time now we go to substitute for the other one. We now substitute for B. B, we will say, according to our formula, According to our formula, it is 6 times 55, 106,000 minus 4120 times times 79,750. You divide by 6 times sum of x squared, which is 2,904,896 minus 4120 times 4120. So once again, give me the answer for that. Give me the answer for B. Okay, 4.54. 4.54. You can see the answers coming. Good. Then A, it is sum of y. 79,750 minus 4.54 times sum of x, 4120. You divide by 6. So once again, give me the answer. When you divide by 6. I can see 10,173.6. 10,173.6 or 0.582. 0.582. 0.582. Thus, cost function is y is equal to 10,173.582 plus 4.54x plus 4.54x. So I think that is what you've been told to do. So the question is now fully answered. So if you are through with that copy, you now tell me to proceed. Marisa, you tell me proceed. Now that is the ideal way that you should present your work. That is the ideal way. Now, for formula, you do the analysis table, you substitute and get your answers. That is the perfect way, which I expect you to use in the exam if they bring this kind of a question. So once you're through, you let me know, you tell me proceed. Siobua, it's not a must. It's not a must, but I would prefer you do it this way. I would prefer you do it this way. This is the surest way. This is the surest way. You can use the calc as a way of verifying whether you have done the right thing. Or if time is on your side, it's not on your side. But this is how I would expect you to do it. Okay, I'm waiting. Oh, proceed zimekuja, Dora, Eliana. I think I've addressed your concern, Eliana, when I was talking to Siobua, Cynthia, Abel, Jude, Waboi, Ikonyo. Good. Good. So question 4, inasema the data below represent the number of students enrolled in a certain college over a 4-year period. Now required the adjusted seasonal component for each of the 4 quarters using the multiplicative model, and then you estimate the enrollment of students in each of the 4 quarters of the year 2019 using the simplest squares. So that is the question of November 2018. Question 4 is on time series. And now what we are drawing is the additive model, not additive, multiplicative. We are told to do the multiplicative model. And you know the multiplicative model, we normally say A is equals to T times S times E. So we always begin with the year here. We have the year. Then we have quarter. We have students. will be our A. Then we have what we call 4 moving average. 4 moving average. Then we have what we call centered average. And this will be our T, centered average. Then I will have estimate index, and this will be A minus T, A minus T. Then we will have accurate index, which we are going to call S. Then we have what we call the seasonalized values. That will be A minus S, you call it Y. A minus S, you call it Y. Then I will have quarter number, which will be our X. Then I will have a column of X multiplied by Y. And then I will have a column where X is squared. So those are the columns that we require for us to be able to answer that question. Oh, sorry. This one you divide. That's the only difference. So We are supposed to have 2015 here. And I told you, you go skipping lines. You go skipping lines. So I skip one. I have 4. 1, 2, 3. So I need then that is for the year 2018. Okay. So we record now the number of students: 70, 100, 80, 60, 50, 40, 120, 80, 90, 70, 70, 40, 60, 100, and then 130. So for the last year, we do not have that. So I'm even supposed to wrap that. It was not supposed to be included. the fourth one. So I do away with these. Because you are not given for the fourth quarter, you are not supposed to include it. So kama umefika hapo, andika the word there. If you are where I am in terms of recording, good. So I can see most of us, we are there. So we can begin. We said what you do, you take the first four values. So 70 plus 100 plus 80 plus 60 divided by 4 is 77.5. 77.5. Now we drop 70, we take 100 plus 80 plus 60 plus 50. You divide by 4, you record here 72.5. We drop 100, take 80 plus 60 plus 50 plus 40. Divide by 4, we get 57.5. Drop 80, you take 60 plus 50 plus 40 plus 120. Divide by 4 is 67.5. We have 50 plus 40 plus 120 plus 80. Divide by 4 is 72.5. 40 plus 120 plus 80 plus 90. Divide by 4 is 82.5. Then 120 plus 80 plus 90 plus 70. Divide by 4 is 90. Drop 120, take 80 plus 90 plus 70 plus 70. Divide by 4 is 77.5. Drop 80, take 90 plus 70 plus 70 plus 40 equals, divide by 4. You have 67.5. 67.5. Then you drop 90, take 70 plus 70 plus 40 plus 60. Divide by 4, you get 60. You record there. Then drop 70, you have 70 plus 40 plus 60 plus 100. Divide by 4. You skip 1 line. You record 67.5. Now drop this 70, take 40 plus 60 plus 230. Divide by 4 is 82.5. 82.5. So I believe we are together at that point. Because Rihanna, we write that way because the value must be written at the center of the 4. So these 4 values you write at the center of the 4 values. And the same applies to the others. Is that okay, Rihanna? Good. Let's now center. Let us center, and centering, you add 2 values, the 2 averages, then you divide by 2 and write at the center. So 77.5 plus 72.5 divided by 2 is 75. You write at the center. 72.5 plus 57.5 divided by 2 is 65. 57.5 plus 67.5 divided by 2 is 62.5. 67.5 plus 72.5 divided by 2 is 70. 72.5 plus 82.5 divided by 2 is 77.5. 82.5 plus 90 divided by 2 is 86.25. 90 plus 77.5 divided by 2 is 83.75. 77.5 plus 7.5 divided by 2 is 72.5. 67.5 plus 60 divided by 2 is 63.75. 60 plus 67.5 divided by 2 is 63.75. 67.5 plus 82.5 divided by 2 is 75. So that means we are still together. We are very, very much together. So if we are together, the next thing is now to come here and divide. We will take 8 divided by 75. Let's confine ourselves to 4 decimals. I hope the space will be enough so that we have 1.0667. If we go by 7 decimals, 4 decimals, then 60 divided by 65 is 0.9231. But remember, you can choose whatever number of decimals you want. But the practice in CASNEP has been we take 4 decimals, but you can take whichever you want. So 50 divided by 62.5 is 0.8. 40 divided by 70 is 0.5714. 120 divided by 77.5 is 1.5484. 8 divided by 86.25 is 0.9275. 90 divided by 83.75 is 1.0746. 70 divided by 72.5 is 0.9655. 70 divided by 63.75 is 1.0980. And then 40 divided by 63.75 is 0.6275. 60 divided by 75 is 0.80. 1.54. This one. Is it the one that you're saying has an issue? That is 120 divided by 77.5. That is what I'm getting. Abel is Are they okay? Any figure that has an issue? Okay. Yeah, Rihanna says they are okay. So if they are okay, we seek to proceed. If they are okay, I seek to proceed. Okay. So from there now, we need to draw the table for accurate indices. We need to draw the table for accurate indices. The table for accurate indices. So computation of accurate indices, whereby we have details here. We have the year 2015, we have 2016, 2017, 2018, we have total here, we have average, and then we have adjusted average. We have adjusted average. So this one you don't have to skip lines, but if you skip, very good. So here we record the values in water 1, 2, 3, 4, and the total. So beginning from here, water 3, I have 1.0667, followed by 0.231, followed by 0.8, 0.5714, 1.5484, 0.9275, 1.0746, 0.9655, 1.098, 0.6275, and 0.8, and 0.8. So what you do from there, you get the totals. So 0.8 plus 1.0746. I'm getting 2.6746. Divided by 3, because there are 3, you record 0.8915 for the 4 decimals. 0.5714 plus 0.9655. The answer is 1.5369. Divide by 2, you record 0.7685. 1.0667 plus 1.5484 plus 1.098. The total is 3.7131. Divided by 3 is 1.2377. 0.9231 plus 0.9275 plus 0.6275 is 2.4781. Divided by 3 is 0.8260. Now you add those averages, 0.8915 plus 0.7685 plus 1.2377 plus 0.826. And I'm getting 3.7237. That is what I'm getting. And because it has not gone to 4, I have now to adjust. And I told you the easiest way to adjust is you retain the first 3. You retain the first 3, 0.7685, 1.2377. Then you ask yourself, the last one must be what? The last one must be what? So it is 0.9. It is because we want them to be equal to 4. We want them to be equal to 4. So the value must be equal to what? So that we get that now must be 1.1023. If you are there and you are okay, say agreed. The total, that is how it should be. If you check your notes, you will find that. Even the other day when you are giving the differences between the additive and multiplicative, we said that it should add to 4. The number of moving periods you have used, that is how it should be. For additive, tukasema it should be equal to 0. Is that okay, Ariana? Yes, it will be 3. Good. So if we have agreed, let us now record those values. Water 1, it is 0.8915. Water 2, 0.7685. Water 3, it is 1.2377. Water 4, 1.1023. Then we start repeating 0.8915, 0.7685, 1.2377, 1.1023, 0.8915, 0.7685, 1.2377, 1.1023, 0.8915, 0.7685, 1.2377. Now, for the purposes of making our work a little bit easier when it comes to the development of the equation, or first of all, at that juncture now we have answered part A. So at that point we have answered part A. Now we want to go and answer part B. So for the purposes of having simpler values to develop the equation, I wanted to have decision right values without decimals. So we'll be rounding them up or down appropriately. So ya kwanza itakuwa 70 divided by 0.8915. And that one is 79. 79. Then 100 divided by 0.685. I get 130. 80 divided by 1.2377. That is 65. 60 divided by 1.1023. That is 54. 50 divided by 0.8915. That is 56. 40 divided by 0.7685 is 52. 120 divided by 1.2377 is 97. Then 8 divided by 1.1023 is 73. 90 divided by 0.8915 is 101. 70 divided by 0.7685 is 91. 70 divided by 1.2377 is 57. 40 divided by 1.1023 is 36. 60 divided by 0.8915 is 67. 100 divided by 0.7685 is 130. 130 divided by 1.2377 is 105. That way, quarter number, we number them quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Then quickly to just a heap. This is 79. This is 260. 65 times 3 is 195. 54 times 4 is 216. 56 times 5 is 280. 52 times 6 is 312. 97 times 7 is 679. 73 times 8 is 584. 1 times 9 is 909. 91 times 10 is 910. 57 times 11 is 627. That is 6 times 12 is 432. 67 times 13 is 871. 130 times 14 is 1820. 105 times 15 is 1575. The one of not 55 but 54. Which one? That is the first year, meant to be 55. This one. This one was supposed to be 16 divided by 1.1023. I'm getting 54. Yeah. Abel, maybe you need to check your figures because this is the same thing you were completing earlier. And from my end, I am having it okay. Now from there, x squared, this is 1, this is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121.
12, that is 144, 169, 196, and 225. Okay. That's okay, Abel? Alright. So from there now, when you add these values, I have 1,79, 2,130, 3,65, 4,54, 5,56, 6,52, 7, 97, 8, 73, 9, 101, 10, 91, 11, 57, 12, 36, 13, 67, 14, 130, 15, 105. So when you seek the totals of these values, the column of X, to your E, I'm getting 120. The column of Y, I'm getting 1193. The column of XY is 9749. And the column of X squared is 1240. So if we are okay, so from there now, least squares function using the seasonalized values. Using the seasonalized values. I'm specifying the seasonalized values because you could also use the originals. There are times we use the originals as X, sorry, as Y. So straight on, we know how to compute B. B is N, that is 15, times sum of XY, that is 9749, minus sum of X, 120, times sum of Y, 1193. You divide by 15 times sum of X square. X square is 1240 minus sum of X. So give me now the answer for B. Give me the answer for B.
Okay, I can see the answer coming, 0.7321.
0.7321. Give me now the value for A, which should be arrived at as sum of Y 1193 minus 0.7321 times 120, you divide by 15.
Nitumie hiyo ya Y nayo ndio hiyo imeanza kukuja 73.68 or 73.67. Aha. 73.68.
73.68. Thus, Y is equals to 73.68 plus 0.7321x. So the next task is here. Where we have the year, we have the quarter, we have the number, and then we have forecast. And forecast, we say it is given as Y predicted times ST. Y predicted times ST. So we were told to predict
for the year 2019.
So it's 2019, quarter 1, quarter 2, quarter 3, and quarter 4.
If we were to continue with our numbering,
this would have been number 16. No. This would have been number 17. Would have been number 17, 18. That's all. Yeah. 19 and 20.
The question will specify when to use what, Eliana. Or rather, Siokua.
The question will specify And how it specifies is by checking whether the requirement to do the equation comes before you deseasonalize. If it comes before you deseasonalize, that is the original. And if it is after deseasonalizing, you are using the deseasonalized values. But the question will specify. Yes, you give it a number. You give it a number, although it's not included. Rihanna, you give it a number. That's why I'm saying if you want to continue numbering, this will be number 17 now, because what was missing would have been number 16. So sasa hapa utasema ni 73.68 plus 0.7321 times 16. Now this one you multiply by the seasonal index that we had for the first quarter, which was 0.8915. 85. Then you do the same thing here. 73.68 plus 0.7321 multiply, sorry, this is 17, not 16. Multiply by 18. Then you multiply by the quarter, which the quarter index, which is 0.7685. We go to the next one, 73.68 plus 0.7321 times 19. You multiply by the seasonal index, which was 12377. And the last one, 73.68 plus 0.7321 times 20, multiplied by the seasonal index for the fourth quarter, 1.1023. So do that and get your answers. Do that and get your answers. Once you have the answers, you tell me finished, so that I'm able to proceed to handle the next issue.
So I can see Abel sending figures, Cynthia agrees. Siobua, I said the question will have specified. The question will have specified whether you're using the original or not the original. I mean, the seasonalized. And if they have not specified, if you see, first of all, you have been told to deseasonalize. And later you are told to develop the equation. That means you are supposed to use these ones. But if they require the equation first, before they tell you to deseasonalize, you should use the original. Is that okay, Siobua? Good. So what I need to say about this question is that when you come across these kind of questions in an exam, you should be very careful when you're handling them, because they can easily mess with your time. Reason being, it appears a simple question and you know for sure it's simple and you know you will get everything. So students start with this question and it takes a lot of your time. By the time you are through with it, more than 1 hour is gone and you still have 4 other questions. So if you have to start with this one, let it not take more than 30 minutes in an exam. Otherwise, it will mess you. You can see even in this lesson how much time we have taken on that question. Actually, today I think we have already solved, we have already answered, or we have answered 2 questions. Yeah. But you can see it has taken a lot of our time. So the point is, ensure if you get it in an exam, it does not take a lot of your time as you try to get the marks. On your own, I would like you to handle question 5A. I would like you to handle question 5A. That is, you differentiate between mutually exclusive events, independent events, joint probability, and conditional probabilities. So that one you will do on your own. You will do that on your own. Is that okay? Actually, they are in your notes, those things. Good. I can see I have 5 minutes. I'm wondering whether I need to begin the next question. I leave it at an incomplete. But I think we should end there. What do you think? Joint probability is not in the notes, but we have been using it. Joint probability is what you get when you multiply more than one probabilities. That's the meaning. Shako. Joint probability is what you get when you multiply more than one probabilities. Quinta says we should end there, and therefore, good, supported by Cynthia. So even Siobua, we end there. We pick up from there next time. Thank you, Jude. Remember to visit the channel where these recordings are posted. And when you are there, you can like the channel and subscribe. Thank you, Waboi. Thank you, Siobua. And good night. Thank you, Abel.